Hello everyone, welcome to today's session. So today's topic of discussion is what is classification, and before moving ahead, please subscribe my YouTube channel. So now let's see what is classification. I hope every one of you must have used Gmail. So how do you think that mail is getting classified as a spam or not a spam mail? Well, there's nothing but classification. So let's see what it is. Well, classification is a process of dividing the dataset into different categories or groups by adding labels. In another way, you can say that it is a technique of categorizing the observation into different categories. So basically, what you are doing is you are taking the data, analyzing it, and on the basis of some condition, you are finally divided into various categories. Now, why do we classify it? Well, we classify it to perform predictive analysis on it. Like when you get the mail, the machine predicts it be a spam or not a spam mail. And on the basis of that prediction, it adds the irrelevant of spam mail to the respective folder. In general, this classification algorithm handled question like if this data belongs to A category or B category, like is this a male or is this a female or something like that. Now the question arises, where will you use it? Well, you can use this for fraud detection or to check whether the transaction is genuine or not. Suppose I am using credit card here in India. Now due to some reason I had to fly to Dubai now. If I am using the credit card over here, I will get a notification alert regarding my transaction. They would ask me to confirm the transaction. So this is also kind of predictive analysis, as the machine predicts that something fishy is in transaction, as it was for hours ago. I made the transaction using the same credit card in India, and 24 hours later the same credit card is being used for payment in Dubai. So the machine predicts that something fishy is going on at the transaction. So in order to confirm it, it sends you a notification alert. Well, this is one of the use cases of classification. You can even use it to classify different items like fruits on the basis of its taste, color, size or weight. A machine well trained using the classification algorithm can easily predict the class or the type of fruit whenever new data is given to it. Now just the fruit, it can be any item. It can be a car, it can be a house, or it can be a signboard or anything. Have you noticed that while you visit some sites or you try to log in into some, you get a picture capture for that, where you have to identify whether the given image is of a car or it's a pole or not. You have to select it. For example, that 10 image, and you are selecting 3 images of it. So in a way, you are training the machine. You are telling that these 3 are the pictures of a car and rest are not. Who knows, you are training for something big. So moving on ahead, let's discuss the types of classification. Well, there are several different ways to perform the same task, like in order to predict whether a given person is a male or a female, the machine had to be trained first. But there are multiple ways to train the machine, and you can choose any one of them. Just for predictive analytics, there are many different techniques, but the most common of them all is the decision tree, which we'll cover in depth. So it's a part of the classification algorithm. We have a decision tree, random forest, naive Bayes, k nearest neighbor, logistic regression, linear regression, support vector machines, and so on. There are many, so let me give you an idea about a few of them. Starting with a decision tree. A decision tree is a graphical representation of all the possible solutions to a decision. The decisions which are made can be explained very easily. For example, here is a task which says that should I go to a restaurant or should I buy a hamburger? You are confused about that. So for that, what will you do? You will create a decision tree for it. Starting with the root node will be, first of all, You will check whether you are hungry or not. If you are not hungry, then just go back to sleep. And if you are hungry, then you have $35, then you will decide to go to a restaurant. And if you are hungry and you don't have $35, then you will just go and buy a hamburger. That's it. So this about the decision tree. Now moving on ahead, let's see what is a random forest. Random forest builds multiple decision trees and merges them together to get a more accurate and stable production. Most of the time, random forest is trained with a bagging method. The bagging method is based on the idea that a combination of learning modules increases the overall results. If you are combining the learning from different models and then clubbing it together, what it will do? It will increases the overall result. Just one more thing, if the size of your data set is huge, then in that case, one single decision tree would lead to an overfit model. The same way to single person might have its own perspective on the complete population, as a population is very huge. However, if we implement the voting system and ask different individuals to interpret the data, then we would be able to cover the pattern in a much more meticulous way. Even from the diagram, you can see that in section A, we have large training data set. What we do? We first divide our training data set into a subsamples on it, and we create a decision tree for each cell sample. Now in the B part, what we do? We take the vote out of every decision made by every decision tree, and finally we club the vote to get the random forest decision. Let's move on ahead. Next, we have naive Bayes. So naive Bayes is a classification technique which is based on Bayes theorem. It assumes that presence of any particular feature in a class is completely unrelated to the presence of any other feature. Naive Bayes is a simple and easy to implement algorithm, and due to a simplicity, this algorithm might outperform a more complex model when the size of the data set is not large enough. A classical use case is naive Bayes is a document classification. And what do? You determine whether a given text corresponds to one or more categories. In the text case, the features used might be the presence or absence, any keyword. So this was about naive. From the diagram, you can see that using naive Bayes, we have to decide whether we have disease or not. First, what do? We check the probability of having a disease and not having a disease. The probability of having a disease is 0.1, while on the other hand, the probability of not having a disease is 0.9. First, let's see when we have a disease and we go to the doctor. So when we visited the doctor, the test was positive. So probability of having a positive test when you are having a disease is 0.80, and probability of negative test when you already have a disease, that is 0.20. This is also a false negative statement, as the test is detecting negative but you still have the disease, so it's false negative statement. Now let's move ahead. When you don't have the disease at all, so the probability of not having a disease is 0.9, and when you visit the doctor and the doctor is like, yes, you have the disease, but you already know that you don't have the disease, so it's a false positive statement. So the probability of having a disease when you actually know there is no disease is 0.1, and probability of not having a disease when you actually know there is no disease, so the probability of it is around 0.90. It is the same as the probability of not having a disease even the test is showing the same results, a true positive statement. So it is 0.9. So let's move on ahead and discuss the KNN algorithm. So this KNN algorithm, or the K nearest neighbors, store all the available cases and classifies new cases based on the similarity measure. The k in the KNN algorithm as the nearest neighbor we wish to take a vote from. For example, if k equal 1, then the object is simply assigned to the class of that single nearest neighbor from the diagram. You can see the difference in the image when k equal 1k equal 3 and k equal 5. Well, the model systems are now able to use the k nearest neighbor for visual pattern recognition to scan and detect hidden packages in the bottom bin of a shopping cart at the checkout. If an object is detected which matches exactly to the object listed in the database, then the prices of the spotted product could even automatically be added to the customer's bill. While this automatic billing practice is not used extensively at this time, but the technology has been developed and is available for use. If you want, you can just use it. One more thing, k nearest neighbor is also used to retail to detect pattern in the credit card users. Many new transaction scrutinizing software application use KNN algorithm to analyze register data and spot unusual pattern that indicate suspicious activity. For example, if register data indicates that a lot of customers' information is being entered manually rather than through automated scanning and swapping, then in that case, this could indicate that the employees were using the register or in fact stealing customers' personal information. Or if register data indicates that a particular good is being returned or exchanged multiple items, this could indicate that employees are misusing the return policy or trying to make money from doing the fake returns. So this was about the KNN algorithm. In the next session, we'll work on the decision tree in more depth. So thank you so much for watching.